Let us have a look at the terminology that we use. Normally, we can use two types of terminologies to denote the terms. For example, here I have written two types of terminologies. In the first one, we read this as T1 or the first term. First term. I repeat, it is not term 1, it is called as first term. So here T2 is nothing but second term. T3 is third term. T4 is fourth term. Similarly, if it is a finite arithmetic progression, the last term will be called as the nth term. The last term is always mentioned as nth because the number of terms changes from one problem to another problem, one sequence to another sequence. We do not know what will be the total number of terms. So we call it as the nth term. You can name it as xth term or yth term, no issues. It's just a variable. N is a variable. Similarly, one more method of using the terminology is A1, A2, A3, A4, so on till An. Here, just instead of T1, we will be using A1. A1 stands for the first term, A2 stands for the second term, A3 stands for the third term, A4 stands for the fourth term. Similarly, the last term will be called as nth term. If I repeat, if it is a finite progression. If it is an infinite progression, we won't be able to mention the last term. Here, if you look at the terminologies now, we can use another form of general term form for each term that is mentioned here. Examples here. A1 is the first term. Suppose I call the first term as A. I can take it as B or C. Any arbitrary number, one variable I am taking here. A. Not an arbitrary constant, a variable I am taking here. A. Now, if this is A and the constant number or the fixed number which I am adding is D, then how do I get A2? I will get A2 by adding D to the previous number. What is the previous number? If A2 is now the succeeding number, then its preceding number is A1. So for A1, you add the fixed digit D. So this is A1, which is also equal to A. Add D to it, you get the next number, that is A plus D. If you are having little doubts, please go back, replay the video from there. Please listen until you understand this idea. That is, the succeeding number can be obtained by adding the fixed number D to the preceding number. So you got A plus D. What is the general form of A3 then? How will you get the third term? Third term is got by adding D to the previous term, that is second term. Second term is A plus D. Let me add one more D to it. I'll get the third term. D plus D becomes 2D. So this will be A plus 2D. Here we go. So if this is A plus 2D, what is A4? A4 is got by adding D to this previous term, that is A plus 2D. So if this is A plus 2D, let's add one more D to this. It becomes 3D. So next term is A plus 3D. That is A4. If you just observe this, just observe what's happening here. Let's see what's happening here. For the first term, we have A. Next term, if it is 2 here, we have A plus D. If it is 3 here, we have A plus 2D. There is a connection between the numbers. The coefficient here, if nothing is returned, it is taken as 1. It is taken as 1D. So if it is 2 here in the subscript, here we are getting 1D. If it is 3 here for the third term, then here it is 2D. The subscript and the coefficient have a connection. See, the subscript is 4, then here the coefficient of D is 3. 4 and 3. So you see a connection there. So can you guess what is A10? Pause the video and try to write the general form of A10. What is that? So I write A plus because all of them are A plus. Then of course there is D, so I will like to write D. How many D's? That depends. It is 3 here, it's 2, 1 less. 4, 1 less. That means it's 10 here, 1 less. That is 9D. So if A10 can be written as A plus 9D. Now let us start guessing few more. What about A25? What is A25? Obviously A plus must be there in all the problems. And if it's 25 here, the coefficient should be 1 less. That is 24D. Right? Easy? Yeah, now you are getting it. Now let us continue from there. Few more examples here. A37. A plus 36D. 37, 1 less is 36. A50. A plus 49D. Similarly, A100. A plus 99D. A996. A plus 1 lesser than this, that is 995D. Very easy, isn't it? So no matter what the number, decrease it by 1. So if you understood this, let us apply this logic to the last number, that is AN. So what is AN? AN must surely have A plus some D. What D? Can you guess what comes here as the coefficient? Whatever number we said as a subscript, minus 1. Decrease it by 1. So here we have N. In that case, I just need more space there. Okay. A plus. Can you guess the number ones, please? Yes. N minus 1. Why N minus 1? Because it is N here. Okay. In that case, if I have M, what is a M? What will be that? That will be A plus M minus 1 into D. See the difference? If it's N, it's N minus 1. If it's M, it's M minus 1. But let me remind you one thing here. The N value always has to be a natural number. Now question is, why it has to be a natural number? Why can't it be negative? Why can't it be 0? Why can't it be a fraction? Why can't it be a decimal? See, let us talk about real life situation. If you're talking about the rank that you got in your class, it must be something like this, either first rank or second rank or third rank, right? Or fourth rank. It goes on like this. Nobody gets 3.5 rank. Not possible. Imagine a race and you win, or you either take one of the positions. So positions might look like this. First position, second position, third position. Nobody ends up with the 2.5th position. Nobody comes like that. You are either the second or the third. There is nothing in between. So you can't tell, I have a position called 2.33. That is not possible. So the N, which is that position, must be a natural number.